Alrighty, class. So today we are going to talk about some review that we have for our quiz that is tomorrow, which is the 23rd of January. And so I asked a couple of people and they said, yes, we would love to see your beautiful review, Mr. Lau. Oh, thank you very much. Thank you very much. But what you'll find here is that the review is very similar to what we'll see in class. So if you're paying attention in class very well, you should be pretty good with this. And if you weren't paying attention in class today, then I really hope you're watching this video. But we're only going to go over a couple of these problems because some of them we're not actually going to see. So we're going to skip a couple of them. And then some questions are also duplicates. So I don't want to double dip in some of these problems here. And so the first couple of problems I'm going to look at is problem 1. And so problem 1, it says that we have to follow the sets of numbers and which one could basically not be a triangle. Okay. And we know how something can be a triangle if side 1 plus side 2 is, greater. Ooh, let me just go ahead and erase that. It'd be easier to just do that. Is greater than side 3. Now, side 1, 2, and 3 are all arbitrary. Okay. It could be any value that we need to. But remember, there's always 3 combinations of this. So not only is there going to be an S1, S2, who's greater than S3, but there'll be a S2 plus S3 and a S1 and S3 as well. Okay, so there's multiple different possibilities here. And so whenever we are looking at this work here, right, we have to go individually by each one. Okay, but we know that if any of the 3 combinations were to fail, then it automatically is not a triangle. And so this problem, we want to find the one that is not a triangle. And so what we'll do is we'll set it up each way. What I have found to be a trick, maybe, couldn't verify it necessarily. It's all not at all empirical evidence at all. Is very anecdotal. So if I take these values, 10 and 17, the 2 smallest values here, and I put it greater than 27 in this case, right? If I could show that that one is at least greater than, that the 2 smallest values are greater than the 3rd value, then I find that a lot of the times it's going to be true that the triangle exists. But the opposite is true as well. If it's lower, then obviously it's not going to be a triangle. But we're going to set up each of the bottom ones set greater to the largest value. And luckily, DeltaMath already gives it to us in a nice little package here. Okay, so we'll start from top to bottom. 10 plus 17 is 27. 27 is greater than 27. Or that's even a weird thing to say. 27 is greater than 27. Obviously, it's not true. 27 is equal to 27. So it seems that A might be the choice we want to look at. But then we have 9 plus 22. 9 plus 22 is going to be 31, which is greater than 30. Which again, what I said earlier was that the 2 lower values, if you add them up and they are greater than the 3rd value, more likely than not, it probably is a triangle. Again, not at all like true factual data around it. That's just how I've seen it so far. But we'll go ahead and keep going. 6 plus 16 is 22. 22 is greater than 19. 4 plus 7 is 11, is greater than 9. And you can do all the other combinations if you want to. But I think at the bare minimum, you should do at least 2 sides, add them together and see how they compare to the 3rd side, the 3rd side being the largest side. But if we were to quickly do that mental math, 22 plus 30 is definitely greater than 9. 30 plus 9 is definitely greater than 22. 16 plus 19 is definitely greater than 6. 6 plus 19 is definitely greater than 16. 7 plus 9 is definitely greater than 4. And 4 and 9 is definitely greater than 7. So because these 3 are for sure triangles, we must choose A to be our answer choice. Move on ahead. And so here we get a segment, and we'll look at question 4, sorry. Looking at segment BD that bisects, oh, that's a terrible line, but that's okay. Segment AC. And we're supposed to solve for x, round to the nearest tenth, blah, 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 all that other stuff, all the jazz. Okay. This is not as hard as we may think. Okay. This is not as difficult as we may think. when we say something bisects another thing, let alone a segment, right? Just the word bisects. We should really think two congruent pieces. Okay. The reason being is that no matter what we're bisecting, it's always going to cut something in half. And those two halves are going to be equal to each other. So if I know BD is bisecting AC, that means point D here, that's my midpoint. And if I have the existence of a midpoint, that means I'm going to have two segments that are going to be congruent to each other. So what we should conclude from here is AD is congruent to DC. But at the same time, AD is equal to DC. And finally, from there, replace those values with the numbers and the variable. 5 equals X, therefore saying that DC, oops, not X, DC is going to be equal to 5. Okay. Truly is not terribly difficult. Okay. Really hoping a lot of us get that right on the quiz tomorrow. And now with these two problems where we have to find the equation of the perpendicular bisector, right? Perpendicular, meaning 90 degrees. Oops. Wow, that was a little funky. 90 degrees. And then bisector, we just talked about bisector as two congruent pieces of the line segment whose endpoints are -5, -5, and 1, -9. And so if I'm going through this problem, right, and I'm methodically thinking this out, I want to start off with finding two pieces of information. One of the information being the midpoint. That's the first thing I'm doing, is finding that midpoint. The second piece of information, I'm going to find that slope. But of course, we can't find either of them if we don't know the formula for them. So midpoint formula is x1 plus x2 divided by 2. So y1 plus y2 divided by 2. And our slope, of course, is rise over run, is what we say colloquially. But the legitimate formula, not this sign, y2 minus y1 over x2 minus x1. Just like so. But we'll go ahead and solve for these. We'll change it up a little bit, make it not all blue. But first, like what are we finding here with midpoint and slope? Like slope of what and midpoint of what? Okay, that's what you might be thinking. We're going to take the line segment with those 2 points and we're going to find the slope and midpoint of that. The reason being is that we want the equation of the perpendicular bisector. So if we don't know what the midpoint and the slope is of our original line segment, we can't find the perpendicular bisector. So we'll find our midpoint. We'll replace these values. We have, really, you could just say, because it's addition, you can say either one is x1 and y1. It doesn't really matter. I'll say -5 plus 1 over 2, comma, -5 plus -9 divided by 2. -5 plus 1 makes it more positive, going closer to 0, which means that this is going to equal -4 over 2. -5 plus -9 is going more negative, so away from 0. We'll have a -14 over 2. And of course, you simplify that down, we get -2, comma, -7. Okay. And so from here, we keep going. We've found our midpoint, good. That's the first box checked. Then for our slope, again, rise over run between the 2 points. And this is where it gets actually more specific. We have to say that our y2 and our x2 is the rightmost point. Because we have that subtraction, we must have it correct. We have to. And so our rightmost point out of these 2 points here is going to be that 1, -9. So we're going to change this to a -9 over a 1. We'll put our minus signs. But since both of the points on the leftmost point, both the values on the leftmost point, are both already negative, we'll change these to a positive and then plug in that value. It's that double negative. And then we add across. -9 plus 5 equals 4. Sorry, -4. 1 plus 5 equals 6. That's going to equal -2/3. But don't be deceived. We do want the slope of our original line segment, yes. But we want the perpendicular line segment, or the perpendicular bisector of our equation here. And so what we're going to do is we're going to find the opposite reciprocal. Okay. And in doing so, opposite implied, or rather, it doesn't imply, opposite means to change the sign, which is going to be a positive because we had a negative from our slope. Reciprocal means to flip the fraction. So our new slope, our m, is going to equal 3/2. And now we're going to finish it off by using the slope that we found here, using the midpoint that we found here, and putting it into our point slope form. Point slope form, of course, is y minus y1 equals m times x minus x1. And what you might be asking yourself is, Mr., I don't know what y1 and x1 come from. I don't know where that comes from. That's coming from our midpoint. Okay, so these are our x1 and our y1. That's what we should be thinking about. That's where we get that from. So after we've done this, we're going to say, well, plug everything in. Y minus our y1 is a -7 because we already have a negative, double negative, change it to a 7. We change it to a positive, then have a 7. 3/2 times x minus our x1 was -2. Change that from that double negative, and we get this as our problem. Now, if this were me, I would accept this answer here. I would take this answer. But because some of the problems that we do on our quizzes and tests and such, they want you to reduce it down as far as you can. And so in doing so, let's just go ahead and reduce it. I'm going to start off with mentally knowing that I have a subtracting 7 at the end here. So I know I have a subtract 7 on both sides. I'm just going to start off with a y equals. But I'm going to do and verbalize all the math that I'm doing. 3/2 times 2, or sorry, times x, is just going to be 3/2 times x. But then 3/2 times 2, because we had to distribute, 3/2 times 2, those 2's are going to cancel out. So what I'm left with is a +3 and then a -7 at the end. And what this final answer is going to be is y equals 3/2 x minus 4. So not too terribly difficult, but it is a bit of a work. You do have to do a little bit more work. But midpoint and slope, realistically, with the amount of math background that we have, I can understand it being a struggle. But we've done so much of it. I'm really hoping that someday, one day, it will click. If not now, hopefully in your other math classes. Move on. Here we have a triangle that has the mid-segment triangle inside of it, which means that all of these parts here are going to be congruent. So EH and HC and FC and FD and GD and EG. Those are all going to be congruent with each other in those various fashions. But something that we never really cover is that the actual segments on the inside of the mid-segment triangle are also in parts congruent. They're going to be congruent with the bisected segments of the parallel side. And so what I mean by that is that this segment HG, that's the one we're looking for. Segment HG is actually congruent with DF and FC. And this the same thing is true about EG, GD, and HF, and EH, HC, and GF. So that's the interesting thing about this mid-segment formula, or this mid-segment triangle here, is that really we have a lot of congruent parts here. But for a lot of us, you're just here to just solve it, right? And so we know two equations. We know 2ms equals a side. And we know ms equals 1/2 of a side. Okay, remember ms means mid-segment. This is basically saying that mid-segment is half the length of side of a side, and side is equal to 2 mid-segments. And that's where we get all these congruencies from. And so if we're looking for HG, we know HG is parallel with DC. DC is 10. So we'll go ahead and plug it in. We'll just say, first off, before that, we'll plug it in with words. So MS, our mid-segment, is HG. Oh, not sure why that erased. It was 1/2 of our side, which we said was DC. Replace our values. We're looking for HG, so to leave it, it's 1/2. DC is 10. HG is going to equal 5. And it actually is pretty easy. Okay, we'll see another example later on that's going to be not necessarily more challenging, but definitely a little bit more interesting. Okay, I got to really put some pep in my step. I got about 12 more minutes, really about 11 more minutes. But even then, 5 of those minutes are a passing period. So I got to really make sure I'm ready. So we'll keep going. We're going to skip example 8. We're going to go with 10. But let's remind ourselves, always to read and annotate, of course. But another thing is I want us to remind ourselves of those equations that we just wrote. So 2ms equals side, and ms equals 1/2 side. And so we look at this problem. We know that W, or rather, no, I'm just skipping all over the place. Okay, I'm sorry. W is the midpoint of TV, and X is the midpoint of UV, which means that WX is a mid-segment because it's the connection of 2 midpoints. We know that WX is 4x minus 7, and we know that TU is negative 7x plus 31. And well, with this problem, right, we have to use one of the equations that we just wrote in. We have to. The reason being is that if we just put these equal to each other, we're finding a value of x that doesn't make sense for our problem. We're basically saying that those two are equal to each other, which we know that the side is 2 times greater than the mid-segment. So we can't say that they're equal to each other when in actuality they're supposed to be bigger, or one of them is supposed to be smaller. Okay, but it works both ways. And so what I tell you to do is use the easier of the 2 equations. Which one's the easier of the 2 equations? Definitely this one. Why deal with the fraction when you don't have to? So what we're going to do, we're going to plug in. So if I were to rewrite this, 2wx equals tu, replace it with the expressions, 4x minus 7 equals negative 7x plus 31. Don't forget to distribute the 2. We get 8x minus 14 equals 7x plus 31. Move all the x's onto one side, move all the numbers onto the other side. I went right to left with my x's, and then pushed all my numbers to the right side. We get 15x equals 45. Then we get x equals 3, because we divide 15x by 15, because both sides are divisible by 15. We get x equals 6. But remember, I'm not looking for x equals 6. Sorry, x equals 3. I don't know why I said 6. But we're not looking for x equals 3. We're looking for TU. That's what we want, TU. So just plug it right back in. Negative 7 times 3 is negative 21. Plus 31 equals 10. Therefore, TU must equal 10. Again, not that hard. Pretty easy, I would hope. So now we have a problem that we're going to see on our free response. And actually the previous problem too, number 10, is also going to be on our free response, but number 11 is also going to be on our free response. Oh man, I keep saying things that are redundant. Number 11 and number 10 are on our free response. Number 11, however, is worth more points. Okay, that's what I wanted to say. Worth more points. So here we're told to identify 4 of our segments: a mid-segment, altitude, angle bisector, and a median. Okay, well, mid-segment is pretty easy usually, right? Match up your midpoint to midpoint. Here I'm looking at my shape of ABC. I see an X has a midpoint because of the 2 congruent signs right here. So therefore X is a midpoint. And then I have the same thing on the other side where our Y is, which means that Y is our midpoint. And so our mid segment is just going to be XY because there's no other segments that can apply here. Then we have an altitude. Remember, altitude is going to go from angle to perpendicular segment. So we start at an angle, looking at all of our answer choices here. I have C, A, and B. I don't have anything that goes to a perpendicular segment except for C. So therefore CZ is our perpendicular segment, which means that is our altitude. Now where angle bisector and median can kind of get blurry a little bit is that our final 2 answer choices are AY and BX. And so if we look at AY and BX, we see that we start at A and we go to a midpoint. That sounds just like median. But if we go from B to X, that's also a median. And so we scratch our heads, we're thinking, oh, I have no idea, because if there must be a mistake on this problem here, but I don't know what the mistake is. That's not entirely true, right? Some things can be true, or multiple things can be true at the same time. So the fact of the matter is we have to accept that both AY and BX are both medians. But what's missing is that we need that angle bisector. Angle bisector is an added layer of specificity that we can use to identify which one is our angle bisector and which one is solely our median. And so our angle bisector, that's our bell, is going to be AY. The reason? We have those congruent signs right there. So we get AY. Then our definitive median, because it's only our median, is going to be that BX. Okay, so I really hope that makes sense. Now for number 12, this is a word problem question. I don't have the time to do the word problem, but I'm going to set it up for you guys. So if we look at ZY, this is going to be 10. We look at ZB, it's 11, and BY is 12. And we're going to basically do what we did in the last problem where we saw something like this with the mid-segment triangle. And if we know that BY is, if we know that Y is our midpoint for BC, then that means that we have 2 congruent sides. CY must be 12. But this is a mid-segment triangle. So therefore that means that everything else must be congruent in some way, shape, or form. And so BZ is 11, that must mean AZ is 11. But then we get to ZY, and ZY says that it's 10, and we don't have any relationship with AX and XC with ZY, at least not that what we've been taught beforehand. But like I said in the previous problem, we said that ZY is basically the same thing as the 2 bisected segments that we find in our parallel side. So if ZY is 10, that means XC is 10 and AX is 10. The same thing is going to be true for XZ. XZ is parallel with CB, CY equals 12, XC equals 12. AB is parallel to XY, AZ is 11, XY is 11. And that's it. After you've established all these values here, all the segment values, you're just going to add them up. So 12, 12, oh, I'm off my page there. So we'll just ignore that. 12, 12, and 12, because I have 3 12s, 3 11s, and 3/10. You can do it like this, or you do the shortcut. 3 times 12, 3 times 10, 3 times 11, oops, 11. That's going to be 36, 30, 33, and that's going to be, oops, not 3, 99. And that's our answer. Okay. Unfortunately, I can't do that last problem, but it's very much the same as this problem we just did. I don't have the time for it, but if you have any questions, I will see if I can answer them. But more likely, more likely than not, I probably won't be. But happy studying. I hope it goes well for you, and good luck on your quiz tomorrow. I will talk to you all later.